Picture this, your manager drops a single sentence on your desk. We get a sales file every morning and I need it in a dashboard by 9. No streaming, no fancy tools, just make it work and make it repeat. That is the job most data engineers actually do every single day. So today we are going to build that exact pipeline together, start to finish from a raw file sitting in cloud storage, all the way to a clean table feeding a chart running on a schedule. Every line is copy and paste ready. This is the real pattern teams run in production. By the end, you will have a working pipeline you can adapt Monday morning. Take a look at the whole pipeline in one picture. Source files land in a stage, then we copy them into a raw table, sometimes with Snowpipe. From raw, we transform the data and from there, it feeds the analytics smarts. Notice the order, we land the raw data first, then transform it inside Snowflake where the compute is elastic. That pattern has a name, it is called ELT extract load then transform. And one more piece wraps around everything. A task puts the whole thing on a schedule so it runs itself. Keep this shape in your head. Because every step we build maps right back to it. Let us ground this in a real example. We can carry through the lesson. Every day at 2 a.m., a fresh orders file lands in cloud storage. Our goal is simple to say and surprisingly common. We want a clean deduplicated orders table feeding a sales dashboard so the business can open it in the morning and trust the numbers. Here is our plan. We build the pipeline once by hand so you understand every piece. Then we schedule it to run every single day, untouched. Build once, run forever. That is the whole game. Before we write code, one design choice. How does your data arrive? If files come in bulk on a schedule, like our daily orders file, you reach for copy into. If files trickle in continuously all day long, you reach for Snowpipe instead. But whichever one you pick, the golden rule does not change. Always land the raw data first, then transform it inside Snowflake. That is ELT, and the reason matters. It is rerunnable. If a transform breaks, your raw data is still safe. Our daily file is batch, so we will use copy into for the rest of this build. Let me give you the mental model that makes pipelines click. 3 layers: raw, clean, and Mart. Raw is the data exactly as it loaded. You never edit it ever because it is your source of truth. Clean is where you type your columns, drop duplicates, and handle nulls. And the Mart is business ready, aggregated, and shaped for your dashboard. Think of a restaurant kitchen. Raw is the receiving dock where deliveries arrive. Clean is the prep station where you chop and season. And the Mart is the plated dish that goes out to the table. Same food, 3 very different stages. Step 1. We create the stage. A stage is just Snowflake's pointer to where your files live in cloud storage. But first we create a storage integration. Here we set type external stage, storage provider S3 and point it at our account. Then we create the stage itself, attach that integration and give it the bucket URL for our orders folder. Here is why the integration matters. It gives Snowflake secure access with no keys, no secrets, sitting in your SQL, your credentials live in one managed object, not scattered across scripts. Set it once and every load from that bucket is safe. Step 2. We define the file format. This tells Snowflake exactly how to read each file. We create a file format, set type CSV, skip the header row, and tell it fields may be wrapped in double quotes. You also set things like null if your date format and your delimiters, set them once, reuse them everywhere. Now here is the gotcha that bites everyone. Most load failures are not your data being wrong. They are a file format mismatch, a stray delimiter, a date Snowflake cannot parse. Get this object right and half your future bugs simply never happen. Step 3. The moment we actually move data, copy into orders raw from our stage using the file format we just built with on error set to continue. And here is the part people love. Copy into loads only new files. Automatically Snowflake tracks exactly which files it has already ingested. So rerunning it will not double load yesterday's data. That single behavior is what makes a daily schedule safe. That on error setting is doing real work too. It decides what happens when a row is bad. We are going to unpack all of those options on the very next slide. Before we touch a single transform, we verify the load. Select count star from orders raw. Then ask one question. Does that number match the row count in the file you loaded? If it does, take a breath and enjoy it. You just moved real data into Snowflake. That is a genuine quick win. But let this become a habit. Always validate your counts before you transform anything. Silent data loss. is the most expensive bug in this whole job. Trust nothing silently. A 5-second count check saves you a 5-hour investigation later. So what happens when a load actually fails? Let me give you the debugging playbook. First, dry run it, add validation mode, return errors to your copy, and Snowflake shows you the bad rows without loading anything. You see the problem before you commit. After a real load, you inspect copy history from the information schema, which tells you exactly what happened, file by file. And that on error setting we mentioned has 3 modes. Abort statement is strict, it stops on the first bad row, skip file drops the whole file, and continue loads every good row and just skips the bad ones. Pick the one that matches how forgiving your pipeline can be. Step 4. We transform raw into clean. Create or replace table orders clean as a select straight off the raw table. Inside that select we do 3 jobs. First we cast types, order belay d to an integer, amount to a number, so columns are no longer loose text. Second, we coalesce the nulls into sensible defaults. Third, and this is the elegant part, we deduplicate, we use qualify with row number partitioned by order ID, ordered by loaded at descending, and keep only row 1. That gives us the latest version of every order, no duplicates. And through all of this, raw stays completely untouched. So you can rerun this transform anytime safely as many times as you want. Now, let me save you from a painful mistake. The wrong way is to cram heavy transforms inside the copy itself or load straight into your final table. It feels efficient, fewer steps, right? Here is why it breaks you. A bad transform corrupts your only copy of the data. And because you transformed on the way in, you cannot replay it. The original is gone, the right way is the one we just built. Land raw and immutable, then transform downstream. That gives you something priceless. Every step is debuggable and every step is rerunable. Step 5. Let us make this pipeline smart. Right now our transform rebuilds the clean table from scratch. Fine today, but a full reload every single day wastes more and more compute as your data grows. Last year's orders do not need reprocessing. So we go incremental. A stream captures only what changed in the raw table. A task runs a merge on a schedule. Here is the one-liner to remember. Stream is what changed, task is when to run, and merge is the upsert that applies it. 3 small objects working together turn a wasteful daily rebuild into a lean surgical update. Here is that incremental pattern in actual code. First create stream orders, stream on table orders, row. That stream now tracks every new row that lands. Then we create a task, give it a warehouse, set a schedule of 1 hour, and inside it we merge. We merge into orders clean using the stream matched on order ID. When a match is found, we update. When there is no match, we insert. That is the upsert doing its work. Now the gotcha that catches everyone the first time. Tasks are created, suspended, they do nothing until you run alter task resume. If your task never fires, that is almost always why. Step 6. The payoff, the analytics smart. Create or replace table mart daily sales as a select from orders clean. We group by order date, sum the amount as revenue, and count the rows as orders. That is it. This small table is what your dashboard actually connects to. Small, fast, and business shaped, your BI tool reads 3 columns instead of scanning millions of raw rows. Now, a fair question, could you use a view instead? Yes. If it is light but when the dashboard needs real speed, materialize it into a table like this. Give the chart something pre-chewed and it loads instantly. We have all the pieces. Now let us orchestrate them. Snowflake lets you chain tasks into a DAG. A child task runs after its parent finishes. So we wire it in order, load the raw, then transform to clean, then build the mart, each one waiting for the last. You also get a choice on compute. Serverless tasks run with no warehouse you manage or you attach your own warehouse. Pick based on the workload. And here is the small magic. You only resume the root task at the top. Every child below it follows automatically. One command and your whole chain comes alive. Monday morning, a pipeline that runs is good. A pipeline you can operate is professional. So let us talk cost and monitoring. First, right size your pipeline warehouse and turn on auto suspend. Pipelines are busty, they fire, do their work in seconds, then sit idle. You do not want to pay for that idle time. Second, watch it. Task history and copy history tell you what ran, what succeeded, and what failed. Wire an alert onto those failures. So a broken load wakes you, not your angry stakeholder. And remember this one, An idle pipeline warehouse left running is the classic silent cost leak. Auto suspend is your best friend. Let us pull the entire build onto one card. Stage, then file format, then copy into raw, then validate, then transform with ELT, then stream and task, then the Mart. That is the whole pipeline 7 moves. And underneath it, 3 principles you can repeat forever. Raw is immutable, transforms are rerunnable, tasks schedule it all, internalize those 3, and you can rebuild this on any platform with any source. Seriously, screenshot this slide. It is your entire Monday morning starter kit on a single card. Let me hand you something for our next interview. When they ask, how would you build a data pipeline? Do not ramble. Answer in 6 clean beats. Stage file format, copy to raw, ELT, transform, stream and task for incremental. Then the Mart, but do not just list the steps, say the why behind them. Immutable raw, rerunnable transforms, scheduled and monitored. That is the part that lands, because anyone can name the commands that structure. Said with the reasoning, signals you have actually shipped pipelines, not just read about them. Look at what you just did. You took a raw file and built it all the way to a scheduled analytics smart, stage, load, transform, incremental updates, and orchestration. That is not a toy, that is the exact pattern you can adapt to almost any source. Monday morning, in our last lesson, you learned why Snowflake separates storage and compute. Today, you put that elastic compute to work on a real ELT pipeline. If you want to go deeper, the full Snowflake masterclass is linked below. And subscribe because next we are tackling cost, certification, and dashboard builds. One question for you: what data source would you point this pipeline at? Tell me in the comments.